Okay, are you guys ready now for the next heatsink? This one again, also a Jeyi, also courtesy of Pablo. Let's take a look. Okay, the heatsink we've just looked at is the Jeyi Finscold iGlacier 8. Now we're going to take a look at the Jeyi Finscold Q150, and this one's copper. This one I'm a little more excited about. I like the size of it. We've got a sealed package. Let's look at some specs. What has me excited about this one, they've got the total W over MK value listed at 401. 401 as opposed to 203 for the Jeyi Aluminum Finscold iGlacier 8. So this should do a whole lot better. And the fact that it's copper. Okay, about this item in tension, this heatsink may affect the use of CPU heatsinks or graphics cards. The height is about 17 millimeter. We'll double check. Please check if there's enough space before purchasing. Heavy duty copper. And it's interesting they give you the W over MK value of the total unit. Usually it's just the thermal pad. And that would be the one thing, depending on the results, that we could change to increase performance. And this one too is CNC aluminum, and they list the Samsung 980 Pro. So that is a PCI Express 4.0 second generation drive, and then the 970 is PCI Express 3.0. So you're looking at a drive difference of the first one being over 7,000 megabytes versus the latter, the second one, being at about 3,500 megabytes. The point of that, the faster we go, the harder we go. Now this one says compatible with all single-sided memory. So I don't know if this will work with double-sided or not. Double-sided meaning like the Sabrent Rocket 4, which is PCI Express 4.0 first generation, it's double-sided. Or a PCI Express 4.0 second generation like the Seagate Firecuda 530. And this is the part that has me intrigued. Full 50-piece copper fins. Those look like individual stamped pieces of copper. So we have a CNC machined aluminum body. So we'll have the wraparound, the aluminum body, and then this stacked copper, which is 50 fins. That's intriguing. So we'll do our unboxing, inspection, installation, and test. Over. It comes in a thinner box. The box is sealed. I appreciate that. And both ends are sealed. And the label, it's kind of hard to read. Let's go in on that. Jeyi M.2 radiator. It's not a radiator, it's a heatsink. Finscold model Q150, aluminum alloy and copper, and for a 2280 SSD. Product dimensions. Well, so far based on the last one, I'm impressed with the results, which is a far cry of what they did with their dual adapter and quad adapter, which were terrible, terrible results. Their adapters would not boot reliably or consistently, let alone test. Okay, in the box, coming out. And again, these beautiful instructions written in Chinese. And we have a QR code that we could scan in and go to their website, which is jeyi.com. Yeah, there it is, jeyi.com. Thank you. And again, our 3 thermal pads, Phillips screwdriver, our screws, and our heatsink in a nice little baggie. Set the package aside. Now, because of the clearance of this, there's a chance, because remember, for those of you not aware, our test, we're looking for 3 primary locations. Number 1, a dual M.2 NVMe adapter. Number 2, a quad adapter that needs a heatsink that does not have one. Number 3 would be on the motherboard, which is where most people are at. So I understand those commenting about that, but that's not where our test started. And then, of course, the last place would be, will this work on a PS5? I believe the numbers we had with the gigabyte copper was 11.6 millimeter. It'll fit. Now, I have read 4 reviews on Amazon. 2 said this will work and 2 said it will not. And what I gather from that, this heatsink we're getting ready to look at will work if you leave the cover off of the PS5. Travel at your own risk. Consider it. Okay, I got the bag open. Let's pull that out. Jeyi Finscold Q150. We're going to have our set of screws, and it looks like there's 1 extra screw here for a set screw. So 1, 2, 3, 4, 5, and a set screw. Nice little screwdriver. And we're going to have 3 pads again. We had that in the last one, which left us kind of questioning why 3 pads. And if this is the same, one of these will be 1 millimeter, so I'll measure them again. We'll start with the bottom for the thinnest one. And that one is 0.4 millimeters. And the middle one, the one that gives me so much grief, that's cut into squares, this one is looks like 0.8 millimeters. And then the top one, this should be 1 millimeter. Yes, 1 millimeter. Okay, now that we have that clarification, and we'll pay attention to the orientation with the notch, and I'll check the screwdriver and see if it's magnetized or not. And yes, this screwdriver is magnetized. It looks like it's better magnetized than the other one. The other one being the Warship. That's the iGlacier 8. So you get an idea in the difference in size. That iGlacier 8 was huge. Now for those of you wondering about the size with the height, there's nothing mounted in there right now, but this will give you an idea overall. The previous one comes in at 35.6. Wow. And this one, and it's sitting in the middle of the holes, so it should be about where it'll be. I'll measure it again when we get there. It's 17.9, but I'll measure it again once we get it mounted. And because we again have elongated holes, we should be able to get pretty good compression on this. We're going to see. And this is the part that intrigues me. Look at all the work with that copper. Ah, there's a plastic lid on top of that. We're going to need to peel that off. If I hadn't seen the reflection, I wouldn't have noticed it. Ah, nice. Finscold. Now this I'm expecting to do great things. After all, it's copper. Keeps it nice and shiny. So those have been stamped and then put into that little box to hold it. Well, I'm eager to test this one. Okay. Because of the size of this, we'll be able to do our 2 tests this time. First test will be on the Supermicro Dual M.2 NVMe adapter, and we'll be testing on the primary location, which is the WD Black SN850. And then we'll change it over to the motherboard, and that'll also be the drive we'll be testing with. So once we mount this, we'll do 2 tests. I like to do a dry assembly first, and the notch we'll want to watch for is alignment on this end, and we're going to want to make sure that we're clear on the back end. So I'm putting a micro screwdriver in between to pry these 2 pieces up, because that's a tight fit, and that is machined as well. There's a groove that fits in. This groove here, see if I can tilt that a little bit so you can see it better. This groove right here, and this groove right here. So we'll want to watch our alignment, and I'll be working from left to right. And because we know what's what with these thermal pads, I won't be using the red pad. And this should work with dual-sided. So I've got to peel one side pad off first. And once I peel one side off, it'll make it a little bit easier for me to then take the scissors, as I did in the last video, working from a straight edge, and trim this to drop that in. Done. Now I have my straight edge. I want to do a dry assembly with the memory right quick, because I want to see my space relations. And that just drops straight in, line up from the left, roll that over holding the memory. We got good clearance for the notch, and again holding the memory. We've got excellent clearance on the rear for that notch, for the connector. Okay, take the memory out, set it aside, and I'm gingerly going to take this pad that I cut one edge on, drop it in, and then kind of roll it. So that edge I've cut off gives me a straight edge, so I can drop this in, and I'll get my alignment where I've centered, because again these are too short. Drop that in, drop it down, and I'm tied up against the edge, and then we'll see if we can peel this top off. This should be one solid pad. That's just my preference, but it would really speed up installation. So whoever the genius was that came up with this idea needs to rethink this idea. There's no point in making something easy difficult. See, the first set of pads, those went down fine, but this second set, I'm going to have to play with them a little bit. Our goal is to keep it simple and make it work. Now the other heatsink said specifically, the Jeyi iGlacier 8, or which they also call the Warship Pro, said specifically to use both pads. So we're again doing that with this one, but it didn't say specifically, but we're doing it. Or if it did, I didn't notice it. Now if I were using even double-sided memory, I think I could still use this thermal pad on the bottom. I don't think I'd have to use that thinner pad. I'm going to just set that in there, and I should be able to drop the memory on that, line it up, or line it up on this edge here on the left, and I should be able to just push that right down in there, and it does. So now we'll be able to take the top thermal pad, and it will cover completely. Perfect. Peel one side off, roll it, and I'm going to work from the connector end first, because when I peel the top off, it's going to stretch just a little bit. Set. Turn it back around, peel that top off, and away it goes. Stretch quite a bit. Pick it up, drop it back down a little bit, and get it back to the right length. Okay, that looks pretty good. Spin that around. Look at that heatsink. Now if that were to fall apart, that would be a mess. They stamped some very thin copper pieces and assembled that into this sled to achieve that. That reminds me of a fastener that used to be around that was a furniture fastener that looked something like that, but a little bit smaller. Same design though. And it mounted in a magazine, but it was a tape magazine. Anyway, I digress. So let's check our notch. Notch is in the right location. And let's get that mounted. And when that drops in, that should compress right about in the middle. Turn it over and take a look. Yeah. Now this one only uses 4 screws, but they have included 5, so 1 extra. So I'll work it the way I did the last one. We'll get 2 on one end, working from left to right, and then as a fulcrum, then I will press and get the other side done. All I want to do right now is get the screws started. And I appreciate the extra screw, as well as a screw to secure the drive with. And I want to be very careful when I'm pressing on this top, because I don't want to damage that copper. So I want to try to press from the side, or what I may need to do is just press. I got this on a solid surface. Press from here and push down so it's not in my fingers. From left to right, turn it around, and again from left to right, so we don't risk damaging any of these little copper sheets. And they are thin. Okay, inspection looks good. The 2 screws they've included, the one for the M.2 drive is tiny. So we have 2 screws left over, and then that little bitty thermal pad, which, to reiterate, I don't think even if you were using dual-sided, I don't even think you'd want to use this pad, because again, to reiterate, we have elongated screw holes so we can get compression. So we'll take our extra parts, bag it and tag it. Okay, let's take another measurement and see, now that we have the drive in, what our thickness is. And we come in at 19.4. So to reiterate, the reason for that is someone wants to use this in a PS5 at 19.4, you just have to leave the cover off. That's a big difference from the Gigabyte Copper, which came in, I believe, at 11.6. And this is 19.4. Okay, enough of that. Now that that's assembled, we'll set the warship aside. Yes, I was impressed with the results. Really impressed. Let's get this mounted. Okay, first test will be on the Supermicro Dual M.2 NVMe adapter. Nice thing about this, cold boot, fairly cold boot from the previous test, but no screw. I've just got a nylon bushing to set. And I like to examine the clearance on the card. I'm always curious about the back, and we clear that one component on the PCB. Good. Not heavy. That is an ideal cooler to put 2 on a dual adapter. And I could see putting 4 of these on a quad adapter if you didn't have a heat sink. Okay, the next part now, we need to get this in the machine. And the test platform. This is the Gigabyte TRX 40 Designaire. We have 2 16-lane slots and 2 8-lane slots. And this first 16-lane slot has a quad card already bifurcated in the BIOS, requires 16 lanes because there's 4 drives. This dual M.2 NVMe adapter is going to go in the first 8-lane slot, again already bifurcated in the BIOS to accommodate 2 drives. First drive, the WD Black SN850, and the second drive is the Samsung 980 Pro. We're only going to test this first drive in this location. Then for the second test, we're going to test in the secondary location on the motherboard, because we have 4 M.2 NVMe connectors. The first 2, 1 and 2, are connected directly to the CPU, and number 3 and 4, which is 1 heatsink for 2 drives, are through the chipset. And the second fastest location would be any PCIe slot directly to the CPU, but not through the chipset. So we should get a good number on this. Now the question about clearance, as this goes into that 8-lane slot, how well does it clear? Clears really well. Now would that work on the motherboard in the primary location under the video card? Okay, this quad card is 1 slot wide. Our GPU is in the second 16-lane slot, and this is an EVGA RTX 2080 Ti, 2 slots wide. Would this work in that slot with that underneath it in that location? No, too tall. But this heatsink that works in this location will also work in the second location on the motherboard, on that M.2 connector. But we will double check it once we get it installed, put the card back in, and see how tight that is. So we'll get the card secure, inventory everything, and then go to the next step. Okay, heatsinks installed, secured. The Supermicro Dual M.2 NVMe adapter is installed and secured. Now we can plug in power, turn it on, energize. We see we have power to the video card. We'll also see our postcodes. Once we hear the PC speaker, once we know that goal is achieved. Power on self-test is secured. We don't need to go into the BIOS, so we'll go straight into Windows. We'll verify that drive for location, and then we'll do our 2 tests. And because we're not in the AMD Hybrid BIOS RAID, or we're not in a software RAID, we'll be able to see the telemetry, smart telemetry, so we can watch the temperature on that thermistor. And by the way, this is BuildOrBuy. Welcome. My name's Gil Boyd. Windows. Windows flag E. This PC will verify the WD Black SN850 is the D drive. And before we get to the test, for those that are asking, it's interesting. Right now the humidity is 41%, the temperature is 84 degrees Fahrenheit. The previous test, I think we were coming in about 82 degrees. So under these lights, it's getting a little bit warm, but you can extrapolate from that for Celsius. I mention that because some asks, there's nothing scientific about this. Do your own testing, your results may vary, but this is what we've been doing, and this is where we're at right now. Windows, but I share it for those that ask. Okay, hardware info. We're going to be looking at sensors only, and we're looking for smart telemetry. We're going to scroll down to the WD Black SN850. The boot drive is a Seagate FireCuda 520. There's the WD Black. We'll be looking at the minimum, maximum, and the average. And we have the Samsung 980 Pro with 2 thermistors. And as it's been pointed out, the secondary thermistor on there is for the chipset controller. And we're only going to be testing that one drive for the maximum temperature. Crystal disk mark, 1 terabyte drive, drive D, 1 gigabyte test file, all. Highlight. First thing we'll establish will be the speed. And the Supermicro Dual M.2 NVMe adapter is PCI Express 3.0 according to the spec. However, the drive that's on there, as you'll notice, this is the WD Black SN850 PCI Express 4.0 second generation, which gets us a little over 7,000 megabytes. And if this were a third generation PCI Express 4.0 drive, we would get right at 7,300 megabytes on the 2 terabyte and up. But what's exceptional on the Generation 3 drives is it gets almost that much speed on the writes. Now on the writes on this, we're going to run about 5,000 megabytes, and we'll get our maximum heat on the left when we get to the second number of megabytes on the right. And our best temperature so far is 48 degrees, and the Jeyi Finscold iGlacier 8 came in at 48 degrees. Now my expectation would be for this Jeyi Finscold Q150 that's copper to beat that. That's my expectation. The test is complete and we came in at 57 degrees. Well, I got to tell you, that's a bummer. You heard my expectation, and I've always said throw that stuff out the door. This is copper and it did not come out as good, and we're in the spot where we should have the best results. It's easier to keep a drive cooler up in the air like that on a dual adapter than it is on the motherboard, which is the next test we've got to do. Let's take a look at the chart right quick before we go to the next test. Okay, looking at the chart, we have on the left, starting with the WD Black SN850 number 1. Bare, that drive is 92 degrees on the dual M.2 NVMe adapter. Number 2, on the motherboard, the TRX40 Designaire second heatsink at 65 degrees. And that's going to be the next test we're going to do in that location, which is right underneath this card, right there. And that's with 1 thermal pad at 65 degrees. And you're going down that line, I've gone ahead and highlighted number 9 because we have now tested 12, 13, this makes number 14. The number 22 is actually 13, which is the Jeyi Aluminum, and that's the Finscold iGlacier 8. And the number 22, which is the one we're doing right now, which is the Jeyi Copper Finscold Q150. And I expected the copper to do better, but wow, we came in at 57 degrees for the first test. So as we look at the results on our heat sinks, we've also tested 3 quad adapters, Asus, Gigabyte, and ASRock. You can look through those numbers, see the past videos, and I've highlighted in red the drive that had the best temperature. Okay, I mention this because our test deviated once we went to the chart on the left, where you'll look at number 10 and 11. We did the ineo, which was active and passive, and then we got down to number 13 and 14, where we did the EKWB on the dual and on the motherboard. Everything above that is all on the dual M.2 NVMe adapter. So for those that want to question the methodology behind this, remember, number 1, we were looking at quad adapters. We went to dual adapters, and from dual adapters the question arose, which we're doing now, answering subscriber questions. What's the best heatsink to use on a dual M.2 NVMe adapter? So then we started the test. We had 6. You guys went to 12. You've now taken it to 14. So the parameters have changed. So I'm trying to help make sense of some of this and understanding the key of how that map fits this chart. And I even had one person suggest rerunning the test. Well, I told him do the math. If it takes me 2 hours to do one test for a video that you see 30 minutes of, that was all of a month's work. No. The tests stand as is. As we go forward, if we have to modify, we'll do it, but I'll explain it as we do it. One other thing we had to do for one of the quad adapters is we had to apply the firmware update to the WD Black SN850. Then the question was asked, did we do the firmware on the Samsung 980 Pro? So both of those drives have had a firmware update. The only one that required it for performance sake was on the Gigabyte Aorus. So it was done for the ASRock. And now it's done with this test. So this test of the 22, as it goes on the dual adapter or on the motherboard, the WD Black SN850 has had the firmware update, and so has the Samsung. But to reiterate, I think the temps are still solid. Number 9, the Acidalie 4-pipe at 48 degrees. And number 21 on the Jeyi Aluminum iGlacier 8, also at 48 degrees. So we have those two that are tied. But my only problem with the Jeyi iGlacier 8 is the size. This thing is just kind of big. It won't work just anywhere. And because I would not be able to use my dual M.2 NVMe adapter, for me that's a no-go. Those slots are crucial. And to reiterate, we have two 16-lane slots and two 8-lane slots. Our primary 16-lane slot, to reiterate, is a quad adapter. It's 1 slot wide. Our GPU, 2 slots wide, is an EVGA RTX 2080 Ti. And our first 8-lane slot is the Supermicro Dual M.2 NVMe adapter, where we've just tested and come up with that temp. That should have been cooler in that location because that tells me it's going to be hotter once it's on the motherboard. And of course, in the second 8-lane slot, we're using a 4-lane Gigabyte Titan Ridge Thunderbolt 3 card, PCI Express 3.0. Everything else, this is PCI Express 3. These other two are PCI Express 4, and the drives are all PCI Express 4. So now we need to run our second test and see how we measure up. Let's take a look at the specs on the drive for that temperature. I showed it in the last video. I need to show you in this one. And this is for the WD Black SN850. The operating temperature is 70 degrees. The non-operating temperature is 85. I had seen on one of these charts 80 degrees, but this says specifically 70. So any heat sink you use is better than no heat sink at all, because you got to remember, the faster we go, the hotter we go. So it's not a big deal for PCI Express 3.0. Somebody commented they had a Samsung 970. I said, well, remember that's PCI Express 3.0, so you're like 3,500 megabytes, which is a big difference than PCI Express 4.0, first generation of 5,000 megabytes, or second generation like we're using of 7,000 megabytes, or even a third generation that's at 7,300 megabytes. All those details matter. So I wanted to point that out so you can see how it goes, get some kind of relevance. Now let's go for test number 2. So I'm going to do a screen capture, Windows flag print screen, close all that out, 57 degrees. Wow, these tests are absolutely fascinating. I opened my mouth, I shared with my expectation, and that was blown out of the water. Crazy, right? Copper's supposed to be better. Yeah, power's off and drained, unplug power. Now we got to pull the card, swap the location. And when we get to that point, I'll bring up the chart again. We'll take a look at it so we can go over it. If you want to do a screen capture, go right ahead. I really like this Supermicro card. I've said this before, and I had no idea when we started this that we were going to be doing all these tests when we started working with this Supermicro card. Let's see if I can get that in without having to take the video card out. Did it. I guess I've been doing it long enough, often enough. I'm getting fairly good at it. About time. Now that little double screw that Gigabyte in their infinite wisdom supplies, and we're now secure on the motherboard. That was pretty quick. Now, I agree this is not a cold boot, but it is what it is. We're already at 57 degrees, and my mind's spinning trying to process that. I really expected better. Power's on, energize, and we're coming up. Power to the video card. We can see our BIOS codes, and we'll hear our PC speaker up here on the right. Once we hear post, power on self-test, and back into Windows we go. There's post. And a reminder, we don't have to go back into the BIOS to look at anything. We don't have to check drives for bifurcation or enumeration, none of that. But anybody else doing this, repeating this, I would suggest you do that. But we've done it so many times, I don't need to. But I do need to confirm the drive that it's seen once we're in Windows. Windows flag E, this PC, WD Black SN850, still drive D, that's the label. Windows found it. We'll bring up hardware info, sensors only. We want to read smart telemetry. We'll scroll down to the WD Black SN850, which is right there. It's now showing a minimum of 43. And remember, we're not going to see the Samsung 980 Pro in the machine because I removed the card. Now what I will do after we test, I'll put that back on when the machine is off and look at my clearance. But I don't see a problem with clearing that. But in case anybody asks, and also clearance with a video card is good too. I've got about 1/4 of an inch with that video card in that second slot. But to reiterate, if the video card 2 slots wide were in the primary and that Jeyi copper Q150, we're trying to be in that first connector right underneath it, wouldn't fit. Too tall. Test. So we're going to be watching our minimum, maximum, and average. Let's bring up Crystal Disk Mark. Still a 1 terabyte drive, drive D, 1 gigabyte test file, all. First we'll establish our 7,000 megabytes, and then we'll get our heat when we get our second number of megabytes on the right. Highlight, and the test is complete, and we came in at 64 degrees. Well, it's not quite what I had hoped for and what I wanted, but it is what it is. I really like the design of that. It's copper. I think it's very unique. I expected better. I really expected better. Let's go back to the chart and see what we've got over there. So right now we know the numbers that we're working with. Based on what WD Black SN850 says, we need to stay below 70 degrees. So our goal is always to try to stay, below that, maybe 65, 60 degrees. And on our chart, we have the Acidalie 4-pipe number 9 at 48 degrees, and number 21, the Jeyi Aluminum iGlacier 8, also coming in at 48 degrees. And now we have number 22 on the list on the left, where we now have 2 tests. The first test at 57 degrees on the Supermicro Dual, and the second test, so there will be a 23 on the list, on the motherboard coming in at 64 degrees. Okay, if you look at the last test that we've just done, where that says that came in at 64 degrees, we can refer back to the chart right here. Number 2, the TRX40 Designator second heatsink came in at 65. So I think you can see the point of that comparison. Now remember, this is not scientific. This is just a starting point, but you have to have some point to start. Changing one thing can change everything. Now, for those of you that have mentioned, that will mention, I'm going to try and say it first so I can save you the trouble. If we put the lid on, will that change things? Yes. If we add fans, will that change things? Absolutely. Remember, this is about what's stock, the product, and keeping things apples and apples. So the lid is off. I've given you the temperature. It's also risen. Since we've been doing these 2 tests, we're now at 41% still for the humidity, but the temperature is up 2 more degrees. 84 degrees Fahrenheit, so you can extrapolate that for Celsius. The point, this is not a scientific controlled test environment. This is a regular test like anybody could do, which is what we've done with all this stuff we've gotten into, because this was about quad adapters, about dual adapters. Then we went down the rabbit hole and through the weeds about heat sinks. So these are the numbers we have so far. So I think it's absolutely fascinating, and we've tested 3 quad cards. We still have another card to test that's not a quad card or a dual adapter, but it'll house 6 drives. That's the Amphitech Squid. So I'm hoping that's going to be the next video you're going to see, depending on the question. So I love you guys. This is BuildOrBuy. My name is Gil Boyd. I appreciate it. Thanks for watching. This is BuildOrBuy. We're on to the next video. We're out.